Hello and welcome to Math Lessons with Linda. Today's topic is working with arithmetic sequences. So let's go ahead and just get right to it. So we are going to use a sequence where our a sub 1 term is 3 and our a sub 6 term is 33. So remember that an arithmetic sequence, the terms are all separated by a common difference. Now this common difference could be a positive number or it could be a negative number, but it's a number that you are adding to get from one term to the next term to the next term. So the first thing that we're going to do with this problem is we are going to find the common difference. And all we know is the first term and the sixth term. So this is how I like to set up a problem like that. I'm going to make 6 blanks. And I'm going to have 3 as my first term and 33 as my sixth term. And I need to figure out what is it that I'm adding every time to get there. So this is what I'm going to do. First of all, I'm going to see what is the distance between 33 and 3. So if I subtract 33 minus 3, I get 30. So in all, I have added 30 to get from my first term to my sixth term. So the next question I need to ask myself is, well, how many times did I have to add that D value on to get 30, right? So I have to go from my first to my second term, from my second to my third term, from my third to my fourth term, from my fourth to my fifth term, and from my fifth to my sixth term. So what it turns out to be is I am adding the same value 1, 2, 3, 4, 5 times. So this is what I'm going to do. I'm going to take the total amount that I know I've added and divide it equally by the 5 times. And so that tells me I had to add 6 every time to get from 3 to 33. So let's check that out and make sure that it works. So if I add 6 to 3, I would get 9. If I add 6 again, I get 15. I add 6 another time, and I get 21. I add 6 another time, and I get 27. And I add 6 my last time, and I end up at 33. So I'm very confident that the common difference in my sequence is 6. So once we have found that, you may be asked, okay, let's find another term. Let's find the 18th term. Now, we could just extend our blanks and we could keep adding 6 over and over and over again until we got to the 18th term. And that is one strategy to use, but it's pretty time consuming, especially if your problem asked you to find the 100th term or a very large term in your sequence. So what we're going to do is we're going to use the formula a sub n equals a sub 1 plus d times n minus 1. And this is the formula, the explicit formula for an arithmetic sequence. And we know enough that we can find the 18th term using this. So what we're going to do is this lower n, this subscript, that is the number of the term we're trying to find. So I want to find my a sub 18th term. The a sub 1 is the first term that was in our sequence, which in this case was 3. The d was the difference that we've just found, which is 6. And this n is the same as this n, the 18th term. So I'm going to do 18 minus 1. So really, I just need to simplify over here. So I have 3 plus 6 times 17. I'm going to move up here. So 6 times 17 is going to give me 102. So I now have 3 plus 102. So my a sub 18 is 105. And I am not 100% sure. I could have made an error, But given that I'm adding 6 every time and my 6th term was 33, 105 seems like a reasonable amount for getting between my 6th term and my 18th term. So that is one problem where you are finding a common difference for an arithmetic sequence and then using that information to find another term later on in your sequence.